Drilling fluids touch just about everything in the drilling process. We're here to deconstruct the drilling process and drilling fluid concepts to provide a deeper understanding of our industry. In each episode, we'll share information, talk to interesting people, and maybe share a few stories along the way. Welcome to the Flowline, a production of AES Drilling Fluids, brought to you by Matt Offenbacher and Justin Gauthier.
Welcome back to the Flowline. I hope everyone is excited to dive into part 2 of our 2-part series with Fred Dupriest. In this second part, Fred's going to discuss the relationship of weight on bit and cuttings transport. We also further discuss limiter redesign workflow. And, ever since last week, Matt, this is something I've given lots of thought about. And I just realized how continuous improvement and performance are simply plan, do, analyze in that cycle with really no finish line.
I mean, there's always a space to improve. And I think it's when you think you've actually reached the limit is when you find yourself kind of falling behind.
Yeah, no, that's exactly right. And so that's one thing that, I think it's a common topic of discussion, whether it's, improvements on how you design drilling fluids or how you apply, product at the rig site. It's just always asking yourself, what's limiting me from getting better? And just even asking, the people around you, hey, what's limiting us? If you're a mud engineer talking to the company man, what's limiting us from getting better? How can I, help reduce that limiter? And just, again, it's comes back to not being satisfied with the status quo. And it's just so interesting how Fred's been able to tie that into every part of the drilling process. So again, I'm excited to dive into part 2. Thanks again, everyone.
Enjoy.
A lot of presentations, talks I do now are about cuttings transport, and which says really boral stability. Cuttings transport extremely easily in a gauge hole, and you should never be weight on bit limited. You're raising your weight on bit. You should never see a pack off in a gauge hole unless you're really fast. Normal flow rates and normal hole sizes, we should be 500 feet an hour, well north of 500 feet an hour before we see pack-offs in a gauge hole. And the takeaway is that if you are seeing pressure spikes or pack-offs, you really need to be suspicious of non-gauge hole. And what do we do about that? Well, we raise mud weight. As I think people generally know now, we don't carry cuttings out of high angle holes, horizontals. They fall due to gravity. They hit bottom, they pile up on bottom, and we develop a equilibrium bed height. The bed stops growing when the velocity gets high enough. You're getting less and less flow area as the bed gets higher. When the velocity up here gets high enough that I can roll the cuttings across the top, the bed stops growing. That's what we call the equilibrium bed height. If I establish this, stop drilling and circulate bottoms up, I do not take the equilibrium bed out. What I have above the equilibrium, because I can't roll that with the velocity at that height. While I'm drilling, what I have above that equilibrium bed is a transportable layer. And this is bouncing around, mostly moving very close to the surface of the equilibrium bed. It's not being carried up here at the top of the hole. It's just bouncing along, and it's really more accurate. And I've seen a lot of full-scale plexiglass testing with rotating pipe at 160 RPM. I've seen a lot of that stuff. And you don't see cuttings being carried. You see them skipping, rolling, or something that sounds like that along the top of this. So the faster I drill, the thicker the equilibrium bed gets. But I don't really change this base bed down here. Now, at really high ROP, as my transportable layer tries to grow, the velocities get really high up here. And if you are drilling too fast and have a gauge hole, you could do it, but you'll start to see pressure spikes because the top of this transporter layer dunes like waves coming into the beach. Every third wave is a tall one, and it has a lot of the same physics. If they try to touch the top of the hole, the velocity is so high that they blow up. And in lab testing, they literally explode. But that puts a pressure spike back up your drill pipe, and you should be able to see that. So if that's the physics of how all of this works, then what is the field practice? Well, we've always, limited to just this drill rate and never had a problem. No, don't be empirical. What can I see? What can I invent? What way of working can I invent? Deterministically to see, know, and decide that right now in my well, this time, this fluid, this rock, that I'm okay, that I can raise the weight some more. And if you invent that, you're going to drill really fast. So we got a lot of operators in the conventionals that won't drill their laterals at more than 300 feet an hour, 200 or 300 feet an hour. And we have other people doing 500 feet an hour, and there's your difference. And it's not small. So the takeaway here, and I really like to have time to develop this, but let me jump ahead and say that the takeaway here is that it's this area that is actually the equilibrium point. If I have enlarged hole, the bed will grow until I have about the same area, because at that flow area, I have that velocity that can roll the top of the bed. So enlarged sections will always fill up, not completely, but this stored mass here, if I disturb it in any fashion, pull a stabilizer into it, bring my pumps on too fast, high percentage of this will mobilize and it will not fit in the gauge hole above. And that's how we pack off. So the answer is don't drill non-gauge hole. And the way I do that is by raising mud weight. Now, how do I know I need to raise my mud weight? At high angle, you've got a very high load, overburden, 10,000 feet is about 10,000 pounds minus pore pressure. And the side load on this might be 70% of that. So our sides of our hole tend to break if we have slightly inadequate mud weight and we get an oval hole. What I will see on my shaker is something that looks like this. You can literally see, this is actually a triangle that pops out. And you can actually see the triangle, that sharp edge of a triangular piece that popped out of the side of that hole. If I have really, and if I see that, I probably need about 0.2 to 0.5 pound per gallon. What happens if I have really inadequate mud weight is that the area that will break out grows, and even the top of the hole will break out, and I get these blocky tabular things. There's the physics, okay, and I'd like to have more time to talk about the physics of how mud weight stops this, but from an operations standpoint, we pretty much know we want to raise the mud weight. How do I know I need to in this well right now, this foot right now? Well, you invent and you implement a cavings monitoring process. You watch what's on your shell shaker. If you don't see anything but cuttings, you have a gauge hole. As soon as you see a caving, you document where that is and you take pictures. Well, how do I get people to raise the mud weight? Now that's really the problem, right? I know I need to raise it now. How do I get them to raise it? Well, that's your workflow. That's your 6 things. Do they all understand the physics of oral stability? Do they all understand what this shape means and why you get this shape? Do they understand what that shape means and why you get that shape? Do they understand why this is a 1 pound per gallon shape and this is maybe a 0.2 pound per gallon shape? Who takes that picture? Who looks at it? Who do they send it to? If you're not taking pictures and sending it, you'll never get your mud weight raised. As soon as that picture lands on the drilling manager's desk, if they don't understand stability, they're asking somebody, how does this work? All kinds of dynamics kick in. Which pictures do you react to? What shapes need to go offset? How many do you empower? How much do you empower your rig supervisor? That shape right there really doesn't mean that you're about to have trouble. It happens a lot in high angle holes. So for that shape, your process is, and you have to create this training, you go talk to the rig supervisor. You got somebody, probably a mud logger or somebody designated to watch for these shapes and take a picture. You go talk to the rig supervisor and you send it in and you talk about it in the next morning. You see that shape, you should have been raising your mud weight yesterday. You don't go talk to anybody. You better have empowered the rig supervisor to say, start mixing bay rat. I'm about to call and wake up the drilling manager. But in the meantime, you be mixing bay rat, right? So how you invent your workflow around the physics that you now understand, and those 6 things that we talk about is more important than the physics. There's nothing on this slide that we haven't known since 1980 and had software to predict since 1980. And yet we could not get any of this done until Limiter Redesign drove us into this process, this 6-step process. And we actually started teaching drillers this bit rock mechanics. So when I teach drillers on the brake handle and directional drillers, rig supervisors, I teach them way more physics than I've talked about today, because there's no other way to get them to change unless it just simply makes sense. Raising mud weight, the collateral risks have to be dealt with. You've got to ask one of those steps. Step 3, what risks do you see? Differential sticking, you better fix that. Increased formation damage from fluid entry, nonsense. I can tweak my filter cake slightly and cut that to 1/100th what it was, versus a small amount of increase I get from differential pressure. Lost returns, that's legitimate. But if I've got a drawn down sand that's dominating that, I can stop, place a pill, stress it up to original integrity, and keep going. There's solutions for those collateral risks. The key is do those solutions before you ask somebody to raise their mud weight, or do them as part of your well plan, if you can see this coming. Okay, here's some other examples, and I've worded these to be a bit, to poke you a little bit. All unconsolidated sands can be drilled as near gauge holes. Reduce your fluid loss, put a filter cake on it, and raise your mud weight. It's borehole instability. Oh, I did that and it didn't work. You've got multi-Darcy sands and you're trying to build a filter cake on it with Bayrite. Or the filter cake, the API fluid loss test is run against 3 micron size holes. Bentonite will plug that. You can get an HTHP of 5, and it's going to go through multi-Darcy hole sizes like, through a goose, right? You need bridging solids. There's physics. So here we go again. What are the actual physics of building a cake in a multi-Darcy pore throat that I can put pressure on so I can stretch that hole out, expand it, and reduce that hoop stress? Okay. So every one of these may seem odd. Some of them may seem odd, but if you really understood the physics, they would all make sense. If you don't understand the physics, you're not going to do any of these the same way. I'm going to skip that. These types of things have to be built. You don't go out and drill a limiter redesign well, or we're going to do limiter redesign on this well. You really have to move your organization philosophically toward understanding how everything physically works, and then building the ability to do those 6 things. What are all the risks associated with this thing? Well, go work that too, and teach that along with the thing you want to do. And that really has to be buried into every phase. All of our continuous improvement things are planned to analyze cycles, and the way they vary, whether it's Six Sigma or Deming or whatever, Kaizen, is simply the steps that we attach to these 3 things. And those really have to be buried. For example, if you require, and I call these mechanical workflow devices, things I build into how I work. So if you require your drilling engineer in the program, or your fluids designer, and you guys write better programs than a lot of companies drill wells from. In your program, if you require them to say for each geologic interval or each change in limiter, what limits me and what am I going to do about it? If that has to be stated by a requirement, plus what are the risks associated with that and what am I doing about the risks? 4 things, right? Those 4 things. If you require that, what engineer is going to say, I'm limited by bit balling. ROP, weight on bit, is limited by bit balling. What are you going to do about it? Nothing. It's not going to happen. So by mechanically requiring, and what are the risks? Well, if I increase the hydraulics, I'll wash the hole out. Well, that's nonsense. Our bit hydraulics don't enlarge the hole unless you're above 400 feet per second, which nobody is, and you're in very soft, less than 1,000 PSI rock. You can't touch that borehole wall. It's too strong. Your hydraulic shear force has to exceed the strength of the rock, and it doesn't. And I've got hundreds of thousands of feet of experience with that. So What's a limiter? What are you going to do about it? What are the risks? Some risks will be real. Do something about them. Some won't. By requiring the person writing the program to simply state those four things, you have just guaranteed limiter redesign with one mechanical workflow change in how you work. So that's easy, right? Well, no, it's not, because that gets politicized. What's your limiter? 100 feet per hour. Oh, whoa, wait a minute. That's not what a limiter is, right? So I'm not going to suggest that changing the workflow is any easier than changing, how you drill the well. It requires persistence like everything else. And I wish I had time to talk about a lot of other things, because it's really interesting how a lot of things really work compared to what the industry thinks. And the really I don't know, engaging thing is that every time you peel another layer of the onion, it seems like we actually discover a different way of working.
Yeah.
All right, so I meant to stop somewhere and let you guys comment or ask questions, but I think this is the end of it.
Okay. Well, I mean, that's certainly, and in a good way, a lot to chew on. And I probably have about a page full of notes and questions. But again, it's, I guess, kind of speaking on it from a very high level, it sounds like not only is it important to sort of follow this 6-step procedure, but I think fundamentally it comes back to the big word, the buzzword that we keep talking about as an industry, is culture. And so, Fred, I'm curious, because listening to it and seeing it and having you walk us through it, it seems so obvious that almost everyone would tend to agree with this. But I guess my question back is what is the limiter for us as an industry as to why we don't adopt this type of philosophy? Because, for example, I've sat in a lot of morning calls with different operators, and years ago, and I'm not going to mention which operator it is, but as we would go around the table, the drilling superintendent would ask the company man and the drilling engineer, what are today's limiters? And that operator, I'm assuming, has went through this. Now, other operators, they haven't. And when asked for suggestions from my perspective, actually in hearing that from the operator about how they would ask the question every day, I said, well, have you identified, the limiters? And it just kind of like went over their heads. And now obviously I can't quite articulate it like you can, but again, going back to it, like, why hasn't this been adopted further than what it has? Because I mean, I don't see it. I would say maybe less than half of operators kind of tend to approach this or have, this type of approach.
So there's several levels really to that. Since I retired 8 years ago, I've worked with many operators, and I don't charge; it's just pro bono. But I may spend 500 hours with an operator doing this. There's a method to this, and each company ideally would try to, if they understood the basics of this, they'd just kind of think about their own company and invent it. And you find that doesn't work really well, because they have trouble envisioning things being really different the way they work. So we kind of work the way we were raised, and that's the bottom line.
Sure.
And this kind of change is really difficult. So I go in and I do an analysis of their limiters based on digital data, and you get most of it right there. I need a little bit of data on rock strength. I need the drilling program. I need the daily reports. I do a little analysis, and I propose training. And Sam Nornier at A&M, he and I work together, and we call these applied drilling research in a way. And I sit down with management and I say, here's what you're really committing to. So I'm able to paint kind of a picture that this is going to be damn demanding, and don't start this unless you're serious.
Right.
So I'm going to go through this. So then I'm going to come back and say, how do you do it? Okay, so the next thing we do is we get them to get everybody, including their fluid specialists for sure, directional drillers, the driller, rig supervisors, engineers, all the way up through the drilling manager in a room for 2 days, for 16 hours of here's limiter, here's how you identify it, here's what you can see to decide in real time, here's what you can re-engineer, and we just go and go and go, and it's intense. And we know from academics that people remember about 15%. Rig people probably remember about 30 or 40% because they have such tremendous instinct. Engineers are the problem if they've not had a lot of rig time. So anyway, you go through 2 solid days. Man, how much management commitment is that? And just being willing to do that demonstrates that management commitment to start with. It really sends a message. So, and then every morning they go back to drilling, and every morning I log in, read their daily digital data, and I send them screenshots that are annotated with, here's what you're doing, here's what you consider, do this, this is your limiter. And we nurture that, and usually they already know before I send them that email. If not, and I'm describing something complicated, they get it in a heartbeat because they had physics-based training. They're not saying, oh, let's drill 3 wells and see if that works. They're saying, okay, I'm going to go about, change my RPM, drop it up, bring it up, and do this, do that, and we'll see what the MSE does. That's the level of conversation you instantly suddenly have. Right. So how does that relate to a company wanting, well, and by the way, as of last year, I've stopped, doing that. There's other things that are occupying me now. But so we're talking about many of the major independents I've been through that process with. And so buzzwords, all of my slides, there's 2 solid days of slides. They're all over the place on all these different subjects. And if you work with one of those companies where you're hearing those words, just ask them for a set of those slides. They may have modified them to focus on their limiters. Hopefully they've identified a performance leader in their organization to kind of lead this effort, because they realize that's the level of change they're looking at and that it's needed. So find out who that is, and make sure that you as a vendor know who that is. Sit down and kind of go through the well and their limiters, and from spud all the way down, ask what limits you hear, what limits you hear. And what you're going to find is that you're going to kind of recognize fluids related opportunities that they may not, because you know a lot more. And so I think that's a role that you could play with them. As far as a company wanted to create this, there aren't consultants who will come in and do this for you. You have to look at things like these 6 steps, the workflow, and you have to think about how you're going to refigure. The primary commitment is that I'm going to try to understand deterministically how everything works, and I'm going to quit saying experience shows. Right. And I'm going to have real-time measurement. I'm going to have step tests. No one's doing step tests. No one's identifying limiters. The step test doesn't just identify the limiter, it puts it in your face every time you do one. There's a dynamic to that. You got to commit to that. So there are a lot of challenges at a low level, and every company I've ever worked with has evolved something that looked different because it matches their business model and their staffing levels and their drilling program, their ability to sustain knowledge with discontinuous program versus continuous. It's all things that affect that. So I don't know if that's very helpful or not to explain all of that. It's just kind of saying it isn't easy, sure, but there is some structure to it. And you've seen a little bit of that on just a few slides here. The bigger high level thing is really where the management level thing and the way we work in the industry is a direct product of management by objectives, and that developed after World War II. And it is that the top person sets objectives for everyone under them. And all they say is come back in a year and tell me if you made them. They set objectives for everyone under them, and it's come back in a year and tell me if you made, and that goes all the way to the bottom of the organization. And it's utterly, absolutely essential you do that. That's how ExxonMobil controls safety, compliance with regulations, project financial performance on projects, is that you just say to the next level down, here's your objectives. If you come back and you achieve them, we win. You may not be perfect, you may not be improving, it doesn't matter. Tell me what this will cost. Promise me that you will deliver this at this cost. I'll do the math, and if that cost makes money, then all I want you to do is deliver that cost. So what happens is that you develop an entire culture throughout your management structure that's all about setting an objective that makes money and then only achieving that objective. So I promised you X number of wells for $60 million. 10 wells for $60 million. As long as I come back in a year and I drill 10 wells for $60 million, then I'm okay, I win. Well, how do I get the $60 million? I look at the last 10 wells and how I drill those, and I know if I don't change any practices, I can deliver that. If I change any practices to try to do better, what happens? They might go wrong. You know, I get, and it's not even that explicit. People don't really think that way explicitly, but it's what happens in the end, is that I only promise what I know I can deliver. And I keep getting rewarded for that. So what we did at one point was that we changed our annual stewardship package to include a list of limiters and what we did about our limiters. And that helped. Because now, but it's very brave, and you're not going to do that until you're well into this and you've gained a lot of confidence that if I follow this process, it will keep delivering. Because it's very brave. Because if you, so we're really careful with that. We still budgeted the same way we always did, but we told a story so that we became winners. We changed the way we work. And because of that, we came in under budget by this amount, under budget. The brave part is that they expect you to do it again next year. Right. So it's not without risk. But managing by objectives, it creates that culture. You're talking about culture. We all tend to have an MBO culture. Unless you're a startup company, a new venture company where you really buy into your whole purpose being to create a new product, a product that people use differently. Nokia didn't fall apart on the smartphones because their product failed. Someone came along with a product that was better. Most service companies now, I think, realize that the life expectancy of any product or concept is pretty short, and it's getting shorter every year because technology is moving so fast now. So I think it's a little easier to sell the idea that if you don't have a process for continuing identifying what limits you, maybe your product performance, maybe your market share, apply the same kind of limiter redesign concept. Stop asking what's broken. What's broken means what didn't go the way I expected it to already. Start asking, I don't care what we're doing now, what limits us from doing more of that? That's the limiter redesign concept. So I use the example of my wife is, if I said to my wife, what's wrong with our marriage? I think she'd say, I don't think anything's wrong with our marriage. But if I were to say, what limits it from being better, you got the paper and the pencil and probably a spreadsheet.
Me and you both.
Yeah.
So, in the big picture of MBO and the necessity of it, somehow we have to find, for big companies, you have to find a way for limiter redesign to live inside of MBO. And the way I describe it is that here's your MBO, it's who you are. You better do it right, safety and all that. And it's very prescriptive. What limits you? Do that one thing and then make that who you are. Now what limits you? Do that one thing and make that who you are. So there's some kind of process of letting you step out and identify a limiter, change it. There must also be a process of teaching that to all your group, internalizing it and making it part of how you work. And that's hard to do. I think that's a challenge with MBO itself is the biggest challenge with going toward continuous improvement. I hate to use that word, but that's where we are.
Yeah, I mean, one thing I appreciate, you're very real in understanding how challenging it is. And I think as a smaller company, we do well at challenging the status quo and realizing some things. But I really appreciate how you pointed out, and you've done this when you presented in March in Galveston before we all got shut in our homes. I remember you presenting and really encouraging that, have the people on the rig floor grade the bit. This shouldn't be something where you get the report back, but go through the exercise. This is a tactile experience where these people, the rig crew needs to be connected and have ownership. It can't just be an office space. Send me the pictures. I'll tell you what's wrong. And I think that's something that perhaps just kind of reflecting on some of the conversation today with, telling our guys to send in pictures of, they've got the grid with, send pictures of the cavings in immediately. But I look at, when was the last time we educated them on what they're looking at? When have they been able to initiate the conversation and keep that close to, where the bit's turning? And so, and beyond that, when you talk about culture, when we're trying to manage fear or trying to get buy-in, it's where our account managers and sales guys, maybe just because it's an engineering problem, we can, going back to the marriage example about, I'd rather be married than right. You may have heard that joke.
Yeah.
Trying to prove to a customer that you know more than them normally doesn't go very well. But if there's a way to connect with their needs or what they're concerned about, you can still solve that engineering problem. And so there's some really good reminders that I think I don't know that I really picked up on today, and I really appreciate you bringing those up again.
Very good.
Awesome.
Well, I am sorry for running over on the time here. This is a bit long.
It was well worth it. No worries at all. Thank you so much.
It was, Fred, it's been an absolute pleasure. And for the audience out there, again, we really appreciate your time and support. If you have any questions, you can hit Matt and I up on LinkedIn, send us an email at the Flowline Podcast at aesfluids.com. Fred, I know you're happily retired, riding into the sunset, but do you have anything that you want to share, any initiatives or anything you want to bring awareness to aside from what was today? I mean, I know you said you're kind of done with sort of doing the whole, operator training type stuff. Has the torch been passed to another gentleman or organization or anything like that? Or are you just...
Well, my class is being taught by Sam Nornyard here at A&M. Okay. And that they do distance learning in that class. And we've kind of figured out that A&M will let us enroll people in that class that aren't really enrolled in the graduate program.
Okay.
They're called certificate students. So every semester that Sam teaches, he usually ends up with maybe 15 students. And the only prerequisite is you have an engineering degree, which is a problem for some people, but you have an engineering degree and Sam says you're okay. That's it. So you send in a resume and your proof of engineering degree. And I don't recall anybody not being qualified to join our class.
That's excellent.
You get their transcripts and they've got a 2.5 GPA, which isn't great, and they're the best student you got. And so Sam and I both have operations backgrounds, and we appreciate people who try. And so there is that and that's a really good class. He's only teaching it now once a year in the spring, but you can contact Sam Nornyard, just Googling.
Okay.
Texas A&M Sam Nornyard, and anybody that's interested in that class.
Perfect.
Otherwise, find companies that are trying to take a run at limiter redesign. Oxy has been a good one, but everybody's kind of in a bind now. But if you can find companies to work with, then sit down and really just show an interest in the process and get them to engage you a little bit more deeply and learn through them. There's another option.
Excellent. We certainly appreciate everything that you do for the industry. I'm sure everything you've done throughout the years will continue to resonate and, such as long as we keep drilling for oil and gas. So again, thank you so much for your time, and we'll certainly be in touch.
All right. Thank you, Justin. Thank you, Matt.
Thank you, Fred. Take care.
Thanks for listening. Please tune in next week for another exciting episode of the Flowline. And remember, may your returns always be full and your trips always smooth. Views expressed in this program belong to participants and not their employees. The program is for informational purposes only and cannot take the place of seeking professional advice. Copyright AES Drilling Fluids.